In this video, we're going to work through some examples using trigonometry and word problems. Two common applications are when you have an angle of elevation or an angle of depression. When you are elevated, you are looking up. When you're depressed, you're looking down. And these are always from a horizontal. So we're always going to be drawing these from a horizontal. So the angle of elevation is equal to the angle of depression because they are alternate interior. When you have parallel lines cut by a transversal, these will be congruent. So depending on if you're looking up, this would be your angle of elevation. If you are looking down, this would be your angle of depression. This would be your horizontal line where you're looking down, or your horizontal line when you're looking up. Let's work through some examples. My recommendation is for you to please first draw a triangle, then label the triangle, and then create and solve an equation. So it says the angle of elevation from point A to a top of a cliff. So we already know we're looking up. This is your horizontal. The angle of elevation is right here. This is 34 degrees. And you're looking to a point from point A, so let's call this A, to the top of a cliff. Here's our cliff. Here's our whatever it is. This is the cliff. If A is 1,000 feet from the base of the cliff, so we're saying 1,000 feet from the base, the bottom of the cliff, this is 1,000 right here. How high is the cliff? Well, if we go across to the cliff, this is my opposite. That is the vertical height of this cliff. And that's what it's asking. How high is the cliff? All right, so across your right angle, this would be your hypotenuse. And we're not going to use that because we don't have a number, or that's not our missing variable. What our missing variable is that opposite side. All right, so that means that 1,000 is adjacent. Let me go ahead and write out SOHCAHTOA so I can figure out which trig of ratio I want to use. If I'm trying to figure out what the opposite is, that's my question mark. And I know the adjacent, well, opposite and adjacent is tangent. So we're going to set up an equation. Tangent of A, and our angle, actually, let's go ahead and write the angle in. It's 34 degrees, is equal to opposite over adjacent. We solve for x by multiplying both sides by 1,000. So 1,000 times tangent 34 is equal to x. This is what we take to Desmos. So let me go ahead and clean these up a little bit. 1,000 times tangent, open parentheses, 34, and that's 674.5 feet tall. That's how high the cliff is. And problem number 2, the angle of depression. All right, so it's always from a horizontal. Here's my horizontal, and it's my angle looking down, this guy. It says the angle of depression from top of an 80-foot building. So we know that this building right here, this is 80 feet tall. And that happens to be the same vertical height on the other side. So the angle of depression from the top of an 80-foot building to a point A on the ground, here's my point A on the ground, is 42 degrees. So this angle is 42 degrees. How far is the foot of the building from point A? So it's asking about this distance here. How far is the foot of the building from point A? Well, that is congruent to this piece of the triangle. Here's your right angle. Let's go ahead and label. Across the box, this is your hypotenuse. I don't want to use that since I don't have a number, and that's not my variable that I'm missing. So I want to use, well, opposite, and I want to figure out what this adjacent value is. So I'm going to use tangent again. Let's set up an equation. Tangent of my angle is equal to opposite over adjacent. Let's solve for the x. I need to multiply both sides by the x and then divide by tangent 42. So x is going to be 80 divided by tangent 42. Let's take that to Desmos. And figure out what our missing value is. And it's 88.8 feet. In problem number 3, we have a blimp hovers over a stadium. So here's my blimp, and it's hovering over a stadium. So here is my stadium. I don't know what a stadium looks like, but it's at an altitude of 125 meters. So I know that the vertical height is 125. The pilot sights a tennis court at an angle of depression of 10 degrees. So I'm going to go ahead and draw from the horizontal. Got to have a horizontal in here. We're going to put the tennis courts over on this side because on the other side is the stadium. So here's my little tennis court. There's the little net right there. All right, so anyway, this angle here is 10 degrees. Find the distance between the tennis court and the stadium. All right, so that's going to be this horizontal distance here. How far? Here's my stadium to my tennis court. All right, so let's go ahead and add a little bit more. I need a vertical side here. I know that's 125, and I need to find this horizontal distance. Okay, let's label. Across is 125, that's my opposite. I need to find the adjacent. So I'm using tangent again. Tangent of my angle is opposite over adjacent. All right, here's my right angle, and just to make sure I'm using the right one, here's the hypotenuse. I do not want to use a trig ratio with hypotenuse. I definitely am doing the right thing here with tangent of 10. All right, so let's solve for x. Multiply both sides by x, and then we'll divide by tangent 10. So x is equal to 125 over tangent 10. Let's take that to Desmos. Tangent equals to 125 over tangent of 10. And that's 708.9 feet. Oh, actually meters, not feet. That's the correct units. All right, one last problem to practice. A ladder leans against an 18-foot house. So here's my house. Here's my ladder leaning against the house. And we know that the height of the house is 18. So I'm going to draw this perpendicular, this vertical is 18. The angle of elevation is 62. An angle of elevation is always from a horizontal. So here's my horizontal. Here's my angle of elevation. And that is 62 degrees. How long is the ladder to the nearest foot? So what I want to do is I want to figure out what this length is. Okay, so from this angle, if I go across, this is my opposite. Here's my right angle, and across the box is my hypotenuse. This time I want to find hypotenuse because that's the length of my ladder. So I need a trig ratio with opposite and hypotenuse, and that's sine. So sine of the angle is equal to opposite over hypotenuse. Solve for x by multiplying both sides by x and dividing by sine 62. So x is equal to 18 over sine 62. This is what we take to Desmos. So 18 over, and I'm going to clean this all up, and type in sine, open parentheses, 62, and that's 20.4. X is equal to 20.4 feet, and that's how tall my ladder is. All right, now it's time to practice.